by Intellipaat. In this video, I will be talking about what is PrestoDB. Presto began as a Facebook experiment to conduct interactive analytic queries against a 300 petabyte data warehouse which was built on Hadoop or HDFS clusters. Prior to developing Presto, Facebook used Apache Hive, which is designed and released in 2008 to bring SQL syntax to familiarity to the Hadoop ecosystem. Hive made a big difference in Hadoop ecosystem by converting a sophisticated Java MapReduce operations into SQL-like queries and allowing them to run at scale. It wasn't, however, tuned for high performance required for interactive searches. Now, before learning about what is PrestoDB in detail, let's look at today's agenda. So, we will be discussing about introduction, query engine, big data analytics, what is Presto, its architecture, and finally, the latest innovation. Now, without a further ado, let's begin our session.
But before we begin the session, make sure to subscribe to our channel and press the bell icon so that you'll never miss any update from us.
Presto is an interactive query technology that could work quickly at petabyte size and was created by the Facebook Data Infrastructure Group in 2012. It was implemented across the organization in the spring of 2013. Presto was open sourced by Facebook in November 2013 under the Apache software license and made accessible for anyone to download on GitHub. Presto has grown in popularity as a tool for performing interactive Hadoop searches, including contributions from Facebook and other firms. Presto is utilized by over 1,000 employees at Facebook who perform over 30,000 queries each day and handle 1 petabyte of data. Now let's discuss about what is a query engine. So a query engine is basically a piece of software that sits on the top of a database or a server and conducts queries against a database or server contents to offer replies to the users or applications. A SQL query engine in particular translates SQL commands and languages in order to access the data in the relational systems. Many people use SQL query engines to perform CRUD operation, which is create, read, update and delete operations, and enforce data policies that are required by relational data models and data management systems. Using a query engine has a numerous advantage. For starters, instead of having to move your data somewhere else, you can bring your query engine to it. A distributed SQL query engine allows you to query your data from a range of data sources, including Hadoop, AWS S3, NoSQL, MySQL, and more, as well as data from several data sources in one query. Presto, Apache Drill, Cloudera Impala, and Apache Spark are some examples of query engine. Now, let's discuss what's the difference between a query engine and a database. As the name implies, database is simply a method of tracking and organizing information that is crucial an aspect of running a business. It lets user to simplify complex queries and include large amount of data in an orderly manner, making it easier for them to explore and identify important data. As the name implies, a search engine is basically a tool that allows users to search for information on the internet, and thus it is useful for locating information created by government, corporations, individuals, and groups. It simply eliminates the need to do manually search for information and does searches at rapid rates. Now, let's discuss about what is big data analytics. So, a big data analytics is the use of advanced analytic techniques to a very large, heterogeneous big data sets, which contain structured or semi-structured and unstructured data, as well as data from many other sources and sizes ranging from terabytes to zettabytes. But what precisely is big data? It can be categorized as data sets that are too large or complex for typical relational databases to acquire, maintain, and process in a timely manner. Big data has a characteristics such as high volume, high velocity, and high variety. Artificial intelligence or AI, mobile devices, social media, and the Internet of Things are driving the data sources to become more complicated than traditional data sources. Sensors, devices, video audio networks, log files, transactional programs, the web, the social media, for example, all generate various sorts of data, and much of it in our real time and are on a massive scale. Big data analytics may help you make better and faster decisions, model and forecast future outcomes, and improve your business intelligence. Consider an open source software such as Apache Hadoop or Apache Spark and the full Hadoop ecosystem as a cost-effective, versatile data processing and storage technologies built to handle volume of data generated by today as you build your big data solution. But the question comes up again, what is PrestoDB? Let's look at further. So, Presto or PrestoDB is a distributed SQL query engine that was built from the bottom up for quick analytic queries on any size of data. Non-relational data sources such as Hadoop Distributed File System or HDFS, Amazon S3, Cassandra, MongoDB, and HBase, as well as relational open sources like MySQL, PostgreSQL, Amazon Redshift, or Microsoft SQL Server and Teradata are also supported. Let's discuss some of the PrestoDB's core concepts. To take the advantage of Presto power and ability to query big data, you must first comprehend the queries engine's fundamental notations. So, first is server types. The coordinator and the worker are two types of servers. The coordinator is in charge of managing worker nodes, processing SQL statements, and preparing queries as indicated by their titles. The coordinator also obtains query results from the workers and forwards them to the client. Next, let's discuss about what are data sources. Connectors, a catalog, a schema, and eventually a table are all covered in the data sources section. Schemas and table are commonly recognized as essential component of a relational database. Let's take a quick look at what a connector and a catalog are. In a nutshell, a connector connects a Presto to a data source such as Amazon S3 or a relational database. A connector can also be compared to a database driver. Second, each connector is associated with a certain catalog. The connector name property must be included in the catalog configuration file. The catalog manager uses this to build a connector based on the catalog description. Finally, a catalog includes schemas and use connections to relate to a data source. The fully qualified table name is always based on catalog. Presto says it when calling to a table. Now, let's look at what our execution model for queries. Presto processes SQL statements and converts these statements into queries that are executed over a distributed cluster of coordinators and workers. And to put it into succinctly, while the notions of statements and queries are well known, the query execution model also includes additional significant concepts such as a stage is a component of queries statements execution. Presto, for examples, create a root and stage and numerous subsequent stages in order to collect 1 billion rows from Amazon S3. The stage hierarchy resembles a tree with one root stage and several other stages that are all connected to it. Although it is logical to believe that stages run on worker nodes, but this is not the case. The coordinator uses them to model a distributed query plan for the workers. Now let's discuss about tasks and splits. Despite the fact that stages do not run on worker nodes, but tasks do. A stage is a set of tasks that are executed and distributed across worker nodes as a part of a distributed query strategy. The distributed query strategy is split down into numerous steps in the Presto's architecture. These are subsequently turned into tasks that processes or obtain data from splits as a part of a bigger datasets. Now, let's discuss about exchange, driver, and operator. These are the final three fundamental components of Presto's model success. At least one parallel driver is present in each task. Each driver processes data and combines operators to produce the output, which is then aggregated by a task and transmitted up to the pipeline, to the coordinator, and eventually to the client. Data is consumed, transformed, and produced by the operators. A query, for example, generates data from a connection, which is then modified and consumed by other operators. Finally, for each stage of the query, an exchange happens between data and multiple nodes. Now, the question comes at what is Presto capable of? So, basically, Presto allows you to query data from Hive, Cassandra, relational databases, and even bespoke data source. Presto can aggregate data from various sources in a single query and enabling analytic across your enterprise. Presto is designed for analysts that need responses in seconds to minutes range. Presto also eliminates the false choice of adopting an expensive commercial solution for quick analytics or a slow free alternative that requires a lot of hardware. So, now the question comes in Who uses Presto? So, Presto is basically used by Facebook to do interactive queries against a variety of internal data repositories, including their 300 petabytes data warehouse. Presto is used by over 1,000 Facebook employees every day to conduct over 30,000 queries that each can scan over a petabyte of data. Presto is also used by major online companies such as Airbnb and Dropbox. Now, let's discuss the architecture of PrestoDB. So, how it works. Presto is basically a distributed system that run on Hadoop and uses an architecture similar to massively parallel processing MPP database management system. It has one coordinator node working in sync with multiple worker nodes. Users submit their SQL query to the coordinator, which uses a custom query and execution engine to parse, plan, and schedule a distributed query plan across the worker nodes. It is also designed to support the standard ANSI SQL semantics, including complex queries, aggregations. Join Presto divides the request into many phases across the worker nodes after the query is compiled. To prevent any needless input-output overhead, all processing is done in the memory and pipelined across a network between these phases. Adding more worker nodes increases parallelism and speeds up the processing. Basically, Presto was built with storage abstraction to make it easy to develop pluggable connections, making it extendable to any data source. Presto also offers a variety of connections because of this, including non-relational database sources such as Hadoop Distributed File System, Amazon S3, Cassandra, MongoDB, and HBase. Now let's discuss how the architecture is designed. So basically, in Presto's design is comparable to any other of the database management system that employ cluster computing, often known as massively parallel processing or MPP. Multiple workers are coordinated by a single coordinator. Clients input SQL statements which are then parsed and planned, after which the employees are assigned to the parallel jobs. Workers collaborate to process rows from data sources and create results for the client. Presto does not write intermediate results to the disk, leading in a considerable speed gain over the original Apache Hive execution paradigm, which is employed to the Hadoop MapReduce process on each query. Presto is a Java application. Presto queries can aggregate data from numerous sources into a single query. Presto has connection for Ologzio files, Hadoop distributed file systems, often referred to as data lake, Amazon S3, MySQL, PostgreSQL, MS SQL Server, Amazon Redshift. Presto, unlike other Hadoop distributed specific tools like Apache Impala, may be used with or without Hadoop. Presto allows for separation of compute and storage and can be installed on premises or in the cloud. Now let's discuss about the latest innovation. The first is Project Aria. For some file formats such as ORC, PrestoDB may now push full expression to the data source. The second one is Presto Unlimited. So, in this project, exchange materialization was introduced in to generate temporary in-memory bucketed tables that require substantially less RAM. The third latest innovation was user-defined function. In the experimental mode, support for dynamic SQL function is also now available. There are docs also available for Apache Pinot and Druid connectors, such as RaptorX, which disaggregates storage and compute for low latency, resulting in a unified, affordable, quick, and scalable OLAP, an interactive solution. Presto on Spark or Presto Code is also run as a library in the Spark executor. So these are the few latest innovation in this domain. I hope you would have liked today's session. So don't forget to hit the subscribe button and click the bell icon.
Just a quick info, guys. If you want to learn big data, then Intellipaat provides a Big Data Architect Master's course. This course is taught by industry experts with more than 10 plus years of experience. This course will help you to land your dream job.